of the morning to you, Joyce.
Hi, Joyce. It's 10:58.
Oh, no, that was really
it's
weird.
Yeah, it was frozen, and then it just suddenly was like, and go.
Like 11 now.
It's 10:59.
Yeah, it's like,
10:59. Hey Joyce, we're doing an example in a packet that I'm going to have back on the desk for you. It's example number 4. I don't think you need to do 1, 2, and 3, but if you want to, go for it. To start off class today. Let's go ahead and pause and work out the example because the other kids have been working on it for a while. All right, other kids who have been working on it for a while. You got it?
No.
No.
Not even close.
Okay, well, while you're working on it, hey, guess what I got?
Ba-da-da-da!
Now, what do we want to change? The car is not my favorite.
Yeah, I was going to say that too.
Can we make
Right?
it a Ferrari or something?
What did we give him? We gave him...
It's so cute though.
Hold on. There we go. I know, but there's not really that much scary. That's what we gave him. So maybe if we can get the car outlined, is that what we want instead, you think? He did yellow, which is good, because then it's only one color. It'll be cheaper that way, and we're trying to go for, yeah, not crazy since there's only 6 of us.
Yeah. But yeah, I would say to make it look more like it goes with the graph, because it looks like it's just something placed on top. Like this looks
Oh,
more
yeah.
realistic.
So he might have to...
Like, I don't think the windows should be...
Oh, is it not working? It's not working.
I have to press the...
Yeah, you're right. Good call. Good call.
Hey, it takes a little while sometimes. I scroll on the mouse.
Oh. Is that it?
Is that a sun? Oh, it's a hitting thing.
Yeah.
I have a problem.
I like that, though.
Yeah,
Right?
I like the, like,
I like that. Do we want this font different, or are we okay?
Let's skip
That's fine.
See? I
Is
get
the
a
yellow
snap.
fine?
Also, isn't it MISS or is it MX?
Oh.
Either way. I believe.
I usually use MISS, but then people were like, I don't know, like when you're older, it's not supposed to be that anymore. And I was like, ah.
Older as in
I
like.
always do MISS.
Yeah.
Older as in like.
Can I do
40 and above.
MISS? I'll change
40 and
that.
above
Yeah.
would be
I
MISS.
say switch it to MISS.
If you guys are good, then I'm good.
Yeah.
40
MISS.
and above.
Sam, are you okay with being the wizard TA?
You don't have to, but we would like you to be up there. But are you going to buy a shirt or not?
He's not listening. Okay, so we don't want this cartoonish. We want it more like outline-ish, right?
Yeah.
And then, do we want it to actually be hitting or no?
Nah.
Not because we're good drivers.
Do we want to take away this bar then and just have like the car driving
Yeah,
the
I
outline?
would say that the bar is unnecessary.
Okay, so we'll take the bar away, the little cartoon POW away, and then have him be yellow or white? Yellow?
Yeah, then.
Okay. So kind of like this one, how it all blends in and he's just like driving on it. Okay. And maybe something cooler than like something from the 60s. Okay.
Good.
But I really like this. I think that's cool. Okay, the front. Are we okay with the front?
Sure.
How do I get to the front? Well, this is complicated. The front, is that good?
Yeah.
Looks collegiate.
Is the L weird or is it just because of that?
Yeah.
Oh, I think it's because he like put it on top of the strings. You know what I mean?
Oh, got it.
So he has it on top of the but that's only because that must be whatever they have
Got it.
in their format.
What
Okay.
if he did put the L on the string there?
Do we want the distressed on the AP Calculus too, or no?
Oh, that'd be kind of cool.
What?
Like, you know how the don't drink and derive is a little bit distressed, see? Do we want
No.
that on this too?
Yeah.
I like it.
Okay.
Yeah.
It's nice and collegiate.
Oh, the way it is?
Scholarly.
But it's up to you guys, honestly. I'm just one voice in
In a crowd of 5.
the crowd. And Joyce, and Sam, and this team.
Do we want the gold outlining still?
I do believe that would make it look very nice.
Yeah, it makes it tie in with the back.
Okay. So keep the gold on both. Keep it, and then that distressed on the back.
Yeah.
All right. I'll ask Joyce too. All right. Thanks. That was fun. Okay. So back. What'd you guys do?
The wrong thing apparently.
Why?
Because I got down to x cubed plus 3x plus integral of 1 over square root of u plus 1 times u. That's what I
What were you supposed to do first?
did. That's exactly what I did. I got 3x squared plus 3 and plus 2 over x
I was
squared.
trying to trick you guys. Well, because that's what the AP guys are gonna do.
Well, the AP guys are jerks.
No, they're just tricky. So that's not for another little while yet, right? And then these canceled out. Then we get a positive 3x squared. So plus 3. We still have n.
What? No, I still did it right.
So that's gonna be a remainder of 4.
Did I? What?
No. It's minus 1. No, it's plus 1. I don't know where no. Yeah, it's minus 1.
Don't you subtract
No.
everything?
It's not. It's minus 3.
Negative.
What?
Negative.
I don't know where I got that minus 1 from.
Because that was a negative, and I distributed in my negative to make it a positive, right? Minus 2.
Shoot, I didn't do that. That's why.
Yeah, that's
4. That's not actually my problem.
Sorry, I messed up on one part.
Okay, it happens.
I don't know.
We're gonna be more careful with our divisions.
Absolutely not.
Or not.
These guys. Wait, isn't it just our tangent?
Mm-hmm.
I
No.
bet our tangent would be an answer choice y.
Oh, it's
It's
minus.
minus instead of plus, but they're gonna try and make you think it is.
It's not our tangent, it's minus.
Just so.
Oh.
So, coming back, I said they're gonna try and trick you and make you think that it's our tangent.
Oh.
Okay, so I'm coming back. I need to go ahead and split up my 4 over x plus 1, x minus 1. Hey, wait a minute, can't we just do one trick? Forget that, let's not do all math, let's just do one trick. So we end up with 3x squared plus 3 plus,
Can't you just pull up the 4 make it like easier?
suppose. Or we could just use it to make that x plus 1 and an x minus 1. So I'm plugging in a positive 1, negative 1, okay. That'd be negative 2, right?
2 negative 2.
And I'm plugging in a positive 1, that'd be positive 2, good. So negative 2.
And then we have.
These ones are nice little U subs, right?
Yeah.
U, du, no big deal, so we end
Yeah,
up
what
with,
did you do with the 4 and the 2?
oh, I used him when we plugged in. I used him to get to the negative 2 and the 2. So like when we plugged in negative 1, it was 4 over negative 2, which is negative 2. So I used the 4, so he's included. Does that make sense? I could have pulled him out, but then I would have had like negative 1 instead. No, negative 1 half u. Part of that's why. So I end up with x cubed plus 3x. That's it. I don't know why. Leading. Yeah. And then we have minus 2 ln of x plus 1 plus 2 ln of x minus 1. Let's see.
There was like these 2 problems straight in a row, or like they're just 2 on homework. There's like a lot of LNs, and I had to keep erasing and going back, and I missed something, and I finally got the answer, and I was just like, I'm done. I don't want to do anything. Then I tried the next problem, and I was like, yeah, let's see what
That was such a good story.
Which one are the ones that you asked about? From the chat?
Yeah, I got to there, and I was just like, no.
Oh,
Let's do.
Yeah.
So if we bring the negative 2 to become a power.
What did I ask?
you could. It was just
I was gonna say it's or
but it would still put it down below, which is what's gonna happen if I did. You know what I mean? Ultimate version. Is that cool?
Okay, cool.
Okay, cool.
Did you ever see the board, by the way?
What?
You looked at the board.
Oh, no, I haven't. Sorry, it's hidden my.
I don't get it.
He's quoting Newsies. We did this one yesterday, so we don't need to do him, but why don't you go ahead and go to example number 5 and say in notes.
Oh, in notes.
Hopefully in notes.
No, in notes, like a couple pages later, you don't have the negative LKT. You just have negative KT.
Just call this 2.
Is that what we haven't gotten to yet? How can I prove something I haven't gotten to yet? Okay, so this one is good though, right? In notes. We were trying to show how to integrate, and the question is, can you integrate? Yes. So then the question is, do we want to integrate? No, right? Okay, let's keep going. Lights minus lift. That gets us to our two most important formulas. This one is lights minus lift. That's going to be the actual amount equation. This one is the rate equation. So you need to go ahead and get to our notes on this. So 7.5b, this is where we kind of left off yesterday, yeah?
Yeah.
Logistic equations.
Wait, are we back in notes now?
Yeah. But keep that close because there's some really good like word problems, etc. to do with logistics.
Oh, second grade transition.
Is that the point?
We look on the converted and
Orthogonal trajectories. Okay, that's super exciting, but the nice thing is we didn't have to. In a previous book, they made us learn about orthogonal trajectories. It wasn't very fun, but we made it. But we don't need to go into all that. That would be more physicsy.
I remember what we're on.
And the more physicsy-ness, yeah, we're like, that's okay. But we did figure out that logistic growth does have exponential growth leveling off at the top, right? And we have our rate, and our rate is proportional to, sadly, the population times the limiting factor minus the population. It's kind of awkward, but still possible, as we saw yesterday. Where are my...
Well, if you want to actually hear an interesting story, Georgia, I thought you were doing Mormons last night. Oh, sorry. Not bad.
Okay. That leads us up to our important endeavor that I don't know what number it is yet. And I'll put that. Tomorrow, specifically, hopefully. Possibly Sunday, if not tomorrow. Depends on whether I'm catching up on reading and breakfast or whether I'm catching up on.
We're turning that.
Yeah, that's what I do.
Checkers.
We'll be excited. Big on every night. Just different things for you to do Wednesday morning, so I'm out till Tuesday, Bible study Monday. So I got home around 10ish. What was yesterday? Oh, tutoring here till late and then tutoring till later. And then tonight, Bible study / a basketball thing. And tomorrow night volleyball thing, but
Christine?
Yeah.
Where's the L in the general solution?
thank you. So we have our differential equation up top. Remember there were different variations, so I'm not saying that this one is the only one you could ever possibly see. However, you should be able to get to this version. You should be able to get to that version. So this is the rate, right? This is the amount, the actual amount of whatever it is that's being measured. We know that this can be all sorts of different things, so we'll just say amount. That's the general solution, lice minus lift. The limit as t goes to infinity of any logistic growth equation is just going to be the limiting constant, the carrying capacity, the L. Which, just for our purposes, remember, we don't want to actually have to think about it too hard. So if we can just recognize L, life gets a lot easier. And then the logistic growth is going to be growing the fastest, increasing the fastest when y equals L over 2. However, if they're asking when, are they asking for what?
What is the rate?
Just if in the question they're asking for when, look at your equations. If they're asking for when, are they asking you to solve for what? No. What are they asking you to solve for? T. When is time, right? So then increasing the fastest, they're asking when is it increasing the fastest? This is the clue. However, we're going to have to use the clue and plug in to find t. But it's still a heck of a whole lot easier than doing what you would normally have to do. Kiddos, if you just see in some general, it's not logistics, some general equation, when is this increasing or decreasing the fastest? What do you have to think of?
Points of inflection.
Ultimately, yes. Thinking of the relative extrema of the derivative, hence looking to the second derivative and finding the points of inflection that, actual points, not possible. We don't want to have to do that, especially with him. Who wants to take a second derivative of him? Nobody. So hence we're going to use this clue and life's going to be a lot easier. And this is widely accepted across AP teachers that it's cool. You just use it and then we're good. Okay, so when? Okay, ready? It's all written out that way. You guys don't have to stress about it. You have it. Example number 6 in your packet, okay? The population of Alaska since from, that's awkward. Good thing I didn't type it. Okay, so we'll just say from. That's awkward. The population of Alaska from 1900 to 2000 can be modeled by the following logistic equation. There it is. Where P is the population and T years after 1900, and T equals 0 corresponds obviously to 1900. So, please tell me you have calculators.
The one day I was in the
I got mine.
The one day. All right, you guys tell me what to do, and then those of us will back up. Okay. So, what do we do for letter A?
Letter A, we need to
Plug in.
plug in 120 for T.
120 into who?
T.
So let's do P of 120. Do you have to really show anything more than that? This is a calculator problem on the AP. No, what are we going to do right now to do it?
Put in our y equals.
Put in your y equals and then do function of. Probably the easiest because it's in our y equals if we need to refer to it later, yeah? How do you get the nice little pretty fraction just in case we need to make sure everything's all nice and
Alpha S1, and then you got the little U over N, or U over
Exactly. So 8, 9, 5, 5, 9, 8. Really? Alpha y equals. And then there's a little box. Isn't that cool?
A cheater shortcut.
All over 1 plus 71.57. Can you guys review the exponent? E to the
Negative 0.0516.
so let's make it x. Is that cool? Then 71.57 and then we got it. Okay, so then I go back. How do we use our shortcuts to get the cool little nifty function notation you do?
Alpha trace.
Alpha you can do there and then over or just straight to alpha trace. There's your little y1 and then say of
120.
122. 7, 8, 1, 2, 1, 7.602. That reserve the right to keep that non-rounded if we're going to use it in the future, which we probably won't. And we're talking about people? Yes, people. It didn't tell us millions or anything, right? It's Alaska. That's maybe we should just take it. Okay, so letter B. How fast was the population of Alaska changing in 1920 and 1940 and 1999?
Is that increasing?
Is it?
Because is L the initial? No, L the limit.
It's lights minus select. So we have L, if we're just going to label stuff, which isn't a bad idea. We have L, we have I, we have C, and this is equal to L times K, right? Negative L times. How fast is the population changing?
Derivative.
Well, L divided by 2 is going to be C. When is it growing the fastest? Hold on. How fast? Isn't that just the derivative? Just the rate?
Yeah.
So we're trying to find P prime of T.
Which we can do on our calculator.
Yeah.
We could. P prime of 20.
40,
P prime of and
99.
now that we have our function, we just do a nifty little derivative trick, right? So we go down, math 8, ddx, right, of y1, alpha y equals
Or you could just do,
x equals 20.
can't you do 6? You do that on the thing, or is it faster on the?
Well, on a graph, you have to actually have
Oh.
20, 40, 99 being shown on the graph for it to actually go to that point. So you're going to mess with the windows anyways. Too. At 20, we have 1678.078. At 40, so it's increasing there, right? At 40, we have 4127.795.
Good, but at a less rate. I just won't know it's the same number, bigger rate.
Yeah, very right. And then 99. 9,741.748. You guys are double checking me, right?
You did.
So it seems to be increasing. Why are no increasing? Because the derivatives are what? Positive. It's increasing, but it's increasing at an increasing
Rate.
rate.
Accelerator.
Huh, okay. Exactly. So that's letter B. Letter C. I don't really like leaving hanging things. You can do that. When was Alaska growing the fastest and what was the population then? Here we go, Amanda. Right? Growing the fastest. Take the second derivative and set it equal to 0 and then test no. All we have to do is what?
Why are we go over 2?
Except put it in context. When P is equal to
44779.
when y equals L over 2, so when P equals 895,598 over 2. Nice. That's the cool shortcut. We don't have to find the second derivative. We just have to know logistic growth is always going to be the fastest at the point of inflection, which is always going to occur at half of the limiting capacity. So we divide that little puppy. However, is this our answer? No. But what is this? What we plug in is y, and don't they ask us for the population then? So we can say the population is 447799 people. We find the population first, and then we backtrack and say, oh, sweet. What time did that occur? Let's go ahead and set our entire equation equal to, how do you use our calculator to do this one?
Big a line.
What do you mean?
Divide everything over. Oh,
Yeah, if we were to actually solve, could we use our calculator though?
Yeah, we can graph it.
We have to graph it and find the, either graph one side and the other and find the intersection, or subtract it over and find the 0. Which one do you think might be a little easier as far as window is concerned? Finding the 0. So I would go ahead and go back to my y equals at the very end of my big old nasty fraction. Go ahead and throw a minus, right? 447799. Time, I'm going to change my window for x to be extended to what, like 150, I guess, maybe? Does that sound good? I'm talking about a range of like 100, it was 2020. So that should work, I should be able to see a 0. And then, there he is, you see him? So then let's go find that 0. Do you guys know you can type in numbers to get your left bound and right bound?
Yeah.
I didn't.
What'd you guys do for the balance? 50? X max is 50?
For my window.
What are you doing for the left bound?
Good question.
I can't figure out where it is because the little thing's not popping up.
Well, I had 150. So it's a little bit more than half.
What's your left on or your X men?
60 worked. I can only tell because the arrow's over there. Well, it goes like positive, negative strangely. Like the Y's are weird.
But what's your X men?
My X-Men was a 0. I just did
So you could do 2. Technically.
Yeah,
I'm gonna do like 60 and like 125. I can do that, right?
Maybe 150 is
82.765039. That was a little intense though. Remember, you just need a change in sign. As long as you have a change in sign, you should be okay. even if you can't see the little cursor. Wait, but what is that in context?
That's how many years?
From?
1990. My goodness. For the max population.
From 19, so it'd be between 1982 and 1983, right?
There we go.
That's what I was going with it.
Maybe the finder that import engine.
Oh, yeah.
There you go.
Also, did you put the population? I also asked for the population.
Oh, I did.
Or short.
It is that first. What information does the equation tell us about the population of Alaska in the long run?
It's gonna keep increasing.
No.
It's
I
gonna
mean, until
fluctuate.
it reaches the population of the aid.
So you can say the carrying capacity or the limit of Alaska's population seems to be, or Alaska's population seems to be limited by, or what was that nice wording? Ooh, there was that nice wording in, where was that? It was in our book. Did I actually copy it though? Maybe I didn't. I think it was probably right here. Come on.
Come on.
Sustainable population. Ooh, that sounds snappy. The maximal sustainable population. Anyway, either way. But basically, it's limited by L, right? This is taking longer than I expected.
How do they know what the limit is unless they like experience it? You know what I mean? How do they know?
Well, yeah, but maybe the study was over, like they were modeling it. I mean, this is looking in the past, right? 1900 to 2000. So they looked at the population trends, and they probably saw it leveling out, and then they made a model. And like they're not saying this is for sure, but it sure seems to be that this is what they, this is what they approximated to be this maximal sustainable.
I like how we deal with the instantaneous values, and yet everything we do is average.
I would say everything is average.
It's like the way they find they find trend, which is average trends.
That's not necessarily average.
Okay.
That's statistics. So you're trying to do regressions. I wouldn't necessarily call regressions averages. Maximum sustainable population of Alaska is seemingly 8,955. Is that 9? 8? You guys can see it better than me. AKA the limit as x goes to infinity is L. Good? How much harder would this have been if we'd actually had to do all the math to solve for it? So what do we need to do? We need to see a problem and recognize, logistic, lice minus lift. Does that make sense? Cool. Example number 7. Uh-oh, now we're dealing with the rate, not the general equation. The AP exam loves to ask questions that require you to recognize the parameters of logistic growth of either the equation or the differential equation written in a different format. Different? Don't judge. I don't know. Wasn't me. This requires you to manipulate the equation to fit one of the two standard forms below. So we already talked about the one on the right. We already talked about the one on the left. Let's do an equation with the rate, okay? Growth rate of a population of bears in a newly established wildlife preserve is modeled by the differential equation dp dt equals, there you go, where t is measured in years. Letter A, what's the carrying capacity for bears in this wildlife preserve? 100. Yep. Wasn't that easy though, as long as we have it memorized? So you can say, sweet, L is equal to 100 bears.
Aww. 100.
Bears.
So does that mean there's like,
Anybody?
that means that, yeah, I know what you mean.
I don't get
The
it.
bears, doubles.
I don't get it.
Misty, does that mean like, it's not possible for 101 bears to be living?
Not seemingly. Not seemingly so. And probably not even 100 because that's the limiting capacity, so it's going to keep on getting closer, but theoretically.
99 is technically the most they can make.
Wow, they can have a tenth of a bear.
Or if they do have a couple more, then maybe some are dying off somewhere else.
You could have one of those bears. What is those kids called that like attach to their siblings?
Conjoined.
Maybe that was good or.
That's something. Okay, so letter A.
Yeah, there you go.
Done. Letter B.
50.
What is the population when the population? What is the population when the population is growing the fastest?
50.
You would have to
That was
integrate.
easy.
Look, you would have thought you would need to integrate to get back to P. True. Or find the second derivative and then find the point of inflection, then go backwards. But you don't, all you have to do is say P is equal to 1/2 of, nice.
And it just asks for
The population at the time, right?
Would this be like an AP question?
What is the rate of change of
This
population?
wouldn't be an entire FRQ, but they definitely do ask growing the fastest with logistic growth. Typically. What is the rate of change of population when it's growing the fastest?
Around 0.00.
So what's it asking for?
They're asking for K.
The rate of change of population, who's that?
20.
Plug it in. They're asking for time. If they were, then we'd have to integrate. But we could integrate, we would just go back, we wouldn't integrate, we'd just go and steal y minus lift, right?
So P equals 50.
And the nice thing is our differential equation is built upon p, so all we have to do is go ahead and plug in 0.008 times 50 times 100 minus 50, which would be 50 yet again.
20.
20?
20 bears per unit time.
20?
I don't think it's 20.
Yes,
it is. I know, I was like, that's weird, but it is.
Oh, it's 8 over 1,000, I was doing 8 over 100.
I'll be too.
Yeah, you were too. Yeah. And technically, what would it be? Ooh, who put units?
Me.
Nice. What was it?
Bears per unit time.
They don't tell you unit time at all?
I don't remember the same thing.
Years.
No.
20 bears per year. God bless the bears.
Good job. Chicago, going for another one?
No,
Is
they're
that- I thought that was Winnie the Pooh.
I thought bears weren't gonna win anything for years. I'm surprised the Cubs won something.
Example number 8. I'm sorry, I started something.
What about the
Example number
Bulls?
8. I still know the weed percent I came up. So,
When went the Bulls? Go Bulls.
suppose the population develops according to the logistic differential equation. There he is. The Bulls used to be big.
Yeah. Michael Jordan was there.
Yeah, you know that.
They went to that.
It's the glory days though. Space
He played
Jam.
the Nationals?
Space Jam came after that.
He played in the Nationals?
I don't know.
And then he
It
went
was
to the
baseball.
Yeah,
You
he
actually
played in the
watched him play
Nationals.
baseball, not
And
that.
then he went to the Wizards for basketball again.
Good point.
Some people are analyzing that.
So question. Are analyzing what?
And America is like in the Michael Jordan on the Wizards phase, but they're still like good, but they're ready to go out soon. And they're just there because
That's interesting, actually. Good
because
analogy.
like they had their peak, and then they're just there because they
What was
broke
the
records and they
baseball?
want more money and stuff.
What was the baseball one?
Yeah, well the
Was it
baseball,
Iraq?
I don't know.
What?
What was it?
You mean $1 million arm?
When was our
No,
date?
No. Okay, here we go. If P of 0 equals, wait, hold on, who is P? We don't even have P. I don't understand.
Haha, you said
Do you have to,
We don't have P of T.
You should factor it out.
you have to say
So
yeah.
what I'm teaching high school is, I thought. Factor what out?
I'm tired.
I know, I do that.
The 0.002p.
0.002?
Yeah.
Because what's my equation?
It.
K-Y.
KY times.
L minus
P.
P.
Okay, so this needs to be alone, right?
Yeah.
Good. So we need to factor out our 0.002. And then, wait, how do I factor them out of that?
You just divide.
I just divide, and what do you get?
100.
Good. Because 100 2 decimal places. 100 minus.
Or two.
Okay, so then, now without doing any math, we know the limiting capacity. That's cool. We didn't have to integrate or anything. So L equals 100. So over here, what if your initial population is 5? What's the limit as t goes to infinity?
100.
What if p of 0 equals 60? 100. What if p of 0 equals 120? Doesn't matter. What? This one will be a weird one that's actually decreasing to 100. Which should be interesting. So sketch the solution curves. We have our 100 right here. Uh-oh, we had 120, sorry. Mm-hmm. Not the right one. There's 100. P of 0 equals 5. What's going to happen? He's way down here. Where is it supposed to be the fastest?
It's 50.
50. This guy's gonna do exponential growth until there, and then he's gonna level out, and then he's gonna go to 1. Okay, what if P of 0 is 60?
And it's gonna just level off kind of a little bit.
Yeah, he doesn't have a point of inflection. Why? Because he can't be 50. So there is no exponential growth. If it's already past where it's going to be growing the fastest, it's just decreasing in its growth. Does that make sense?
Acceleration is decreasing?
Um,
Acceleration of increase?
the acceleration is negative. The rates are decreasing.
What's the point of a jerk?
Because the
Are they decreasing or are they global? Oh, yeah.
whiplash. All right, so 120.
How do you do that?
Negative.
Weird, right?
But then both the curves are decreasing, but one of them's increasing.
Well, two of them are increasing. Like the actual curves are increasing. One of them, the rates are increasing and then decreasing. The other one, the rates are decreasing, and this one, well, it's decreasing. The rates decreasing. Does that make sense? Sketch the solution. Oh, we just did that. Done. Done.
So if you have one,
Sorry.
Wait, it asks for 100 inflection point.
that means that you have more than the capacity, so everything's dying off or whatever it is.
Yes.
So can you actually have 101 pairs,
Yes. You can.
and then you would go back to 99 and
We would theoretically be fluctuating. Remember, we're just mathematically modeling, which is the ideal. Some people say mathematicians, but this is the ideal.
That's
so math of magicians living.
Ooh.
Magicians.
Inflection point. The only one with an inflection point is P of 0 equals 5 because he's the only one that can go through 50. Does that make sense?
yeah.
So he's speeding up in that guy. Okay, last one. At least from our packet. I think, is it the last one?
Yeah.
Example number 8. The rate at which the flu spreads. Ooh, there it is. Here comes the flu. Through a community is modeled by the logistic differential equation. Boom. If P of 0 equals 50, solve for P as a function of T. Wait, what? They're making us integrate?
Yeah, those jerks.
They are?
No, you just need to memorize when it's licked, right?
Exactly. So P of T is equal to
Integral.
nice. We need 1, we need the
Plus
uh-oh,
E.
but we have C and we have E to the negative, and then we have 3,000
K.
times K and then times T. We don't even have everybody.
We'll
Hold
see.
on.
Who can fall.
Hold on. Who's up here?
Oh my god, they gave us the bloody information.
That is KY times L minus Y.
Yeah.
So who's K? 0.001. So what's 0.00?
3.
It's negative 3.
0.001 times 3,000. Move it 3 places and you get.
Oh, and C is initial. Right?
How is the initial?
Uh,
I mean, you can.
right? Is that what we want to
P
make
of
it?
Oh yeah, because they give you a point. It's an initial value problem. You plug in 0, and it's 1 plus C over
I
under
don't
3
think it's not just initial though. We have to use the initial to find C though.
That's what you said.
I was trying to respond specifically to Meg's question,
Oh.
saying that it's not initial, but we're going to use it. So therefore, when we go ahead and plug in, we have 0 and we have 50. So you go ahead and set 50 equal to 3,000 over e to the anything to the 0, e to the 0 is just 1, so we have 1 plus c, true? So multiply up, divide over, we end up with 1 plus c is equal to, cut out of 0, 60. C is equal to 59. Does that make sense?
Quite interesting.
Why? So then they want the actual equation, I think, true? So you go ahead and just plug it up.
Plugging and chugging at the same time.
You multitask. Okay. Letter B. I'm not going to go through and actually solve, but just we know what to do, right? If they want population when t equals 2 days, just be careful. They might do something funny, right? I put it in hours and then say days and just make sure your units match up. But 2 days is easy. All we have to do is plug it in, right? And then letter C. Use your solution to A to find the number of days that have occurred when the flu is spreading the fastest. What do we do?
3,000.
When P equals 3,000 divided by 2, which would be 1,500. The question, is that the answer to Good question.
No.
No.
Only
So what do we have to do?
days that have a curve that frees the fastest. Plug that into the formula.
Are we gonna solve by hand and waste time?
Now we're gonna drag and chug into our calculator.
Okay, logistic growth. You got to see some stuff in a worksheet. We got to take our notes in the sense of getting down what we have to memorize. But as you've seen, that memorizing is going to make these questions a whole lot easier, right?
Yeah.
That's just silliness. That's just silliness. We know what to do. There's homework. You guys got it? Homework due on Monday.
What sheet?
Oh, it's just the one you just did that we did together. Don't worry.
Marble plus. See how that is doing today?
What does the word require you? Huh?
How it is doing today?
Oh, I'm seeing through to the basketball thing, so I'll probably just be working.
Oh, you don't watch it?
Yeah, part of it. Maybe not all of it.
Is he gonna make my house
I figure since I'm at the timing table, like I'm supporting them all year anyway, or when season starts, so I'll start early. We'll see.
Can I put this